Good morning, everyone. Good afternoon, good evening, wherever you guys joining from. So the topic that we're going to talk about today is obviously AI for product managers. We are going to be specifically talking about Gen AI, when someone should leverage Gen AI, when should they not. This session gives you a framework on how do you approach as a product manager when you're trying to implement AI in the organization, especially Gen AI. Anupama, thank you for being with us today to help us with this session. And the mic is over to you.
Thank you, Sharath. Let me start off by sharing my screen here. All right. Happy Friday, everyone. I'm Anupama Garani. I currently lead enterprise AI initiatives, which is focused on moving Gen AI systems from prototype to production. My work sits at basically the intersection of product strategy, data readiness, and the evaluation framework. And I heavily am focused on RAG, which is Retrieval-Augmented Generation, and basically building guardrails and measurable reliability within these products. So the pattern that I've seen is over the last 2 years, it's really easy for us to build a demo with all of these shiny tools and AI new frameworks that's being brought in the marketplace, but it's really difficult for us to ship this reliably. So here I'm today to talk about the same clear pain point. I'll share a practical roadmap today based on that experience. And I think from there, if you have any questions, you could definitely ask me. So we are here basically to cut out all the hype that you see on LinkedIn and all the different places with respect to AI, and we will actually dive into the practical roadmap. All right. So let's see why GenAI usually fails to reach production. When I mentioned that it's easy for us to really spin up a demo and show that in a Streamlit or even a Claude Code, and it's very difficult for us to reach production, these are the 5 key reasons that I have seen in the industry, which really basically enables all of these products to not be pushed to the marketplace. So the first thing is the prototype trap. So when you are wipe coding using tools such as, let's say I use Claude Code, we use GitHub Copilot, and there's more tools that's coming in, it's really us who's being stuck in iterating over and over this UX, not being able to solve a specific problem. So that's the first prototype trap where we're just stuck in the POC version of it. Secondly, we don't really have an evaluation data set. Basically, what are we trying to do? How are we trying to evaluate? Are we measuring the accuracy, precision? This would basically lead to infinite loop because we don't really have a stopping criteria. Thirdly, there's a lot of latency cost. So as you know, LLM is basically a generative AI technology, which means the amount of time it takes for us to see the response is really directly dependent on the success of the product. Now, imagine you're asking a question to Google and it or ChatGPT or any of the new LLMs. If it takes about 5 minutes for you to get the response, I don't think you'd be retained as a customer anymore for that product. So latency costs are real, and I've definitely seen this a lot in many industries. When they ship from demo to production, they see that the latency increases because they have various number of steps. Fourthly, data privacy. Giving all the data to LLM without really consenting the privacy would really be a violation. So I've seen a lot of different news articles these days where highly ranked executives are just feeding this data to the LLM, which is actually very dangerous for the reputation of the company and the individual. So data privacy is real. And finally, non-problems. Using LLMs for all the problems is definitely not the best way because LLMs don't have deterministic logic or deterministic response. A simple example for you could be you try asking a question to ChatGPT today, and you ask the same question after a few minutes, you would not get the same response word by word. That's because it's not really deterministic, it's probabilistic because it's probability models. That's LLM. So these are the key reasons why the project stagnates, or even after it gets into production, it takes a while for users to start adopting. All right, so we talked about the failures. Now let's see where Gen AI really fits in the product lifecycle. Let's look at it from a product manager's perspective. So basically, the first one is the discovery. You first see if the problem really needs LLM or any sort of Gen AI solutions. A lot of times, the problems could just be solved using automation, and we don't really need Gen AI. So this problem solution fit is going to take a while. We would need to iterate. You would need to get to the root cause of the problem by speaking with the subject matter experts and the users who are using this product and really understand if Gen AI is even the solution. And at this point, the proof of value is the key milestone, which is basically not the concept. Proof of concept is different from proof of value. So you would identify which of the problems are worth solving at this stage. Secondly, once you realize that, okay, maybe Gen AI is the solution, how do you approach this? You would start off with basic prompt engineering and not agents. Agents is overhyped. You would need to maximize the benefit that you get with prompt engineering and basic RAG and user feedback loops. So what this means is you can literally spin up a small RAG solution within an hour or two. And when I say RAG, I'll get more towards the end on what exactly it means, but it's basically you providing all of the data to the LLM through a specific pipeline. And the LLM uses this data to respond as opposed to giving ChatGPT's generic response. You would then test this with the first 10 beta customers who would be a good representative of a large population of your customers. And then finally, once you get the feedback from these customers, that's when you start designing to go to production. And the designing basically includes some of these important and often overlooked components. So this could be evaluation frameworks. I'll speak a little bit more towards the end about this, guardrails, latency, which we already talked about, and reliability. So overall, what we need to make sure is the system is 100% reliable and it's doing what it's supposed to, and without harming the reputation of the company. And finally, the scale. This is where I've seen a lot of projects actually fail as well. They do reach the production, they start seeing a lot of adoption, but when it starts scaling rapidly, there's so many things that could break. The most important thing would be the cost, because with Gen AI, each token costs a certain number of dollars. So when you're scaling high, just keep all of these things in mind, and you would need to optimize for cost, for latency, sustainability, making sure that it's actually giving you the ROI which it's supposed to. Right. Now, let's see what exactly is deterministic versus probabilistic. I touched a little upon it, saying that not every problem would need an LLM solution. Let's see why that is the case. So, this shift from traditional software to Gen AI LLM happened just in last couple of years. So up until then, about 30 to 40 years, we've been seeing 100% predictable and deterministic solution. What exactly does that mean? So we have a logic. For example, the user logs in, the user sees these sort of sites, and then they do the specific action. So we have really clearly well-defined use cases as well as the test bench on what the flow is. But right now, if you see the output of the Gen AI software is not really predictable, which means the user A can get a different response for the same question with respect to user B, because Gen AI is probabilistic, it's not really deterministic. And also, the kind of solution could also vary on the prompt. So if I were to prompt just giving bare minimum information to ChatGPT, I wouldn't see that big of a detailed response. Versus if I am giving a lot of context about myself to ChatGPT, and and then asking a question, I would be seeing way different answers. So that's the probabilistic, creative, and the variable nature of Gen AI. Secondly, we have seen with traditional softwares, we had a fixed infrastructure. We knew that this much amount of storage is going to cost this much money. But with respect to LLM, this is going to be highly variable because per token cost is really high, especially when you go to production and you start scaling it, you start seeing that the costs rack up very immediately. Thirdly, the speed. So we would measure the latency in terms of milliseconds when we would load the website, when we see the user sign in. All of this would happen in milliseconds. But unfortunately, with Gen AI, that's not the case. It would take seconds and sometimes even a minute or two, if, depending on the architecture which you have and the logic, if it's complicated. And that's what we call this the inference latency. So inference is basically when the Gen AI provides you the response and how much time it takes for the response. We have a lot of different strategies that we could use to reduce this latency. We have something called the streaming, which means it would start responding in just few milliseconds once you start asking the question, as opposed to the traditional way of Gen AI working. And finally, the use case. Previously, we would have the calculations, which is the basic, even if you're booking a flight ticket, even if you're making any sort of transaction, it's all pre-written logic. And it's basically the CRUD, which is you create it, you create the rows, you update the rows, you delete the rows, you do some sort of calculation on that data point, and you have a business logic. But now the landscape has shifted towards synthesizing, reasoning, and the extraction, which is more closer to how humans work in general. Let's see the 4 filters for prioritizing the Gen AI use cases, right? So at a high level, the first one would be the frequency. Is this a high volume task where automation provides massive time saving across the user base? That's the first thing that you would need to see. Like how many times would a specific task need to be implemented over and over? That's one of the first thing that you would need to see for the use cases which involve Gen AI. Secondly, if you were to use a manual workload, how much of a cognitive load would that cost? Like, for example, you have a specific representative who's looking through thousands of documents looking for an answer. How much of a pain is that? That's definitely a lot. So that's a very good place where we could use Gen AI. Thirdly, data readiness. This is a huge blocker sometimes for Gen AI. How clean is your data? Does the data have all the necessary metadata tagging that's needed for Gen AI to understand what it means? Let's say your database has a specific column and it does not really have much description. In that case, the Gen AI or LLM is not going to be able to help you. So how accessible and clean is the data? And finally, error tolerance. Error tolerance is super important in various industries such as finance, medicine, as well as legal. If any sort of hallucinations happen, how much of money or reputation is that cost? That's something which you definitely need to see before you even use Gen AI in the use case. Right, so now we talked about high level, what are the things that's needed, filters for Gen AI. Let's go to the data readiness checklist. I think this is one of the most important prerequisite that's needed for enterprise Gen AI to productionalize successfully. So there's various aspects to this. Let's look at the structure first. Let's see if you have a bunch of data points about customers. Do you really have the metadata about that customer? Let's say you're running something just like food applications such as maybe Zomato or Uber Eats. Do you have a bunch of customers who have signed up for your application? You have a bunch of food catalog. Do you really have the necessary metadata for each of these to make sure LLM can actually work well? If I am a vegetarian who's asking for, let's say, I want some sort of fast food, is your food catalog specifically tagged to metadata, which says, does it contain meat? Does it not contain meat? Vegan, vegetarian, and all of the data points. That's metadata. Secondly, freshness. How often is your catalog being refreshed? Like coming back to the same Uber Eats and Zomato example, if a specific restaurant stops basically preparing some sort of food, do you reflect that on your database? Do you have that updated? Do you have a flag which represents that? Because you cannot really show something which you don't have, and LLM is going to pick that up, and then people just call this hallucination, but it's not really. Thirdly, access control. So this would be more applicable where the database has data which is of very high importance. So this could be trade secrets, it could be company strategies, it could also be salary of executives. Do you have necessary controls so that you are preventing common analysts or folks who don't really have that amount of executive presence to look at these data points? Fourthly, quality. How's the quality of the data that you're sourcing? Is this from the right place? Is there someone in the loop, or is there some sort of a check that's being done to see if the data is clean, if the data is not redundant, duplicate, or basically having any sort of missing metadata points? And finally, the volume and context. This is so important because the LLM would have only specific number of tokens until which it can retain the sort of quality. And once you start flooding the LLM with a lot of data, the response that you get, if you observe, would also be very less. So you would need to make sure this is very controlled, it's fresh, as well as it has a good structural metadata before you even pass this to LLM. Now, let's look at the more technical side of this, the architecture decision matrix, and this would be the type of implementation for your specific use cases. So you might have heard of each of these terms on LinkedIn, right? RAG, agents, and assistants. What exactly does each one of these mean, and do you need all of them to make your product a success? Definitely not. You would definitely not need everything all at once. But I can explain what each of these mean. So the first one is retrieval augmented generation. It basically just means when you're asking a question to LLM, it does not really have the context about your company's data. So that's when you would need to pass all of your company's data based on the previous data readiness checklist, which I mentioned. So this could be, let's say, a bunch of PDF documents, a bunch of presentations, and also maybe a lot of different metadata associated with that. Using all of that data, LLM is basically able to respond to you correctly without hallucination and without really using internet knowledge or outdated knowledge. So that's RAG. So RAG is best for use cases which involves a lot of documents. Let's say you have like 600, 700 documents, which needs to be accessed regularly on a daily basis by a specific group of people. So that's when it's very useful. And a lot of companies, of course, have used documents which is unstructured, overstructured, such as SQL or Cosmos DB is also a different type of database, but RAG is used for unstructured data best. Secondly, agents. So agents is nothing but LLM along with API calls in order to complete some sort of a multi-step goal. So if you think about it, you could use agents for doing a specific task, such as scour the internet, look for a specific information, and provide a summary of this to me every morning at 8 a.m. That could be a very small example of agent, and this is helpful in huge automation pipelines where you'd be able to do a quick analysis. You can also get quick extraction of the data points and also do cross-app operations. And finally, assistance. So if you see all of these travel booking websites and also any website for that matter these days, you see a small chat pop up on the right asking how can I help you, and it's usually a bot which asks you if you need any help. So they basically are wired with all of this knowledge, almost very similar to RAG, but it's not still that very helpful because these are still assistants who are using the knowledge of the documents. But it could be personalized as you include the agents. When you start providing more and more information about the customer, it could actually help you creating a personalized plan. So what are the key risks in RAG? Let's look at the first one, which is the RAG. What's the architecture look like, and is there any risk for using it? So the architectural flow basically looks like this. The user asks a query to the model, and on the back end, what basically happens is when you pass a document, this document is parsed into chunks. So if you pass, let's say, 2 pages, each of this page is splitted into across like 5 or 10 chunks. So that's going to be like assuming 10 chunks per page, there's going to be about 20 chunks. And each of these chunks are then converted into something called as vector, which is a mathematical representation of a word. And this would be stored in something called as vector DB, which is a vector database. There's a lot of different types. There's Cassandra, there's Azure AI Search Index, there's more. So it basically enables semantic search. What does semantic search mean? So when you ask for, let's say, what's the customer's birthday, and the database has their date of birth, the semantic search is able to magically relate these two concepts. So when you ask birthday versus the document has date of birth, it's actually able to understand that and provide you the value. So VectorDB is useful for this sort of semantic search. And thirdly, context retrieval and ranking. This is again, when you ask for a birthday, it basically gets you all the different chunks which is related to date of birth, and it's able to rank based on the criteria that you have provided. Let's say it's Jason's birthday, so it's able to rank all the Jason and put that on the top. And if there's Mary Jane or different names, that's going to be ranked low within that retrieval. And finally, prompt context injection. So this would mean you're injecting the user query and any context about the user. So if I am the user who's an executive who's asking about this person's birthday, then I would give the response which is more aligned to that executive as opposed to an analyst asking about it. And finally, LLM grounded response. So when you get a response from, let's say, Perplexity, you see on the end something called as the sources, which means you're able to see what sources did it glance through to make this answer for me. So that's so important in the Gen AI, and we call that grounding. So that's LLM grounded response. So that's the architectural flow. Now let's see what's the risks when we productionalize this. Firstly, retrieval noise. So let's assume you have a lot of different customers. You have Jason with different surnames, and you want a different Jason, but maybe it's not ranked high enough. So that's what we call as the retrieval noise. Maybe there's a lot of irrelevant Jasons that it's clouded your retrieval space, so you're not even able to get that answer. Secondly, context stuffing, which is it's exceeding the token limits. If you provide, like, let's say, flooded with 10 or 10,000 or 20,000 documents, maybe the chances are you might not even see the response in the first 5 or 10 chunks. That's context stuffing. And finally, the security and privacy. A lot of times I've seen identifiers such as date of birth, SSN. These are the things that needs to be protected. And there's no masking that's done when you productionalize it. And that's a huge danger and a red flag for any sort of LLM. So always make sure when you have an identifier, a personal identifier such as MRN, SSN, or EIN, or date of birth, you always mask this. There's so many different techniques that you could use. Even a simple Python regular expression can help. So these are the different risks that is associated with RAG. All right, now let's move on to the agent, which is the second one. So what exactly is an agent? And let's see instead of an architecture, let's see the loop for this agent. So we basically define what the goal of this agent is. Like I mentioned, if I want a summary of all the things that's happening in AI in current landscape, that's the goal. Secondly, it would be the planning and reasoning. So you would provide what sort of a plan it needs to follow. You could say, hey, you can look at CNBC, you can look at TechCrunch, and maybe you could also look at LinkedIn. And then you can come back and report to me what the most important AI related news is on these three websites. So that's the planning, which you basically provide to the LLM. And the tool selection, this could be an API to CNBC, an API to LinkedIn, an API to TechCrunch. You basically add your access code, you add your API keys, and you enable the LLMs to use these tools as they need it. And once you're done with all these three things, then you see the complete agent work in magic, because at this point, you've given the agent a goal, what needs to be done, which is look in the internet for the news about AI. Secondly, planning. You tell, okay, you have to look at these three websites, and then you actually give it the permission to look at these websites using API. And finally, you just run the chat completion API, which is the execute in the equivalent of the agent language. So it's basically able to provide you the response every single morning at 8 a.m. about AI. What are the production risks with agent? Sometimes the goal which we define and provide to the LLM might not be the goal which it thinks it is. So when I say, give me the AI news, maybe it thinks that, okay, I don't maybe have sufficient news. So I'll keep looking for the user because maybe there's not a lot of news about AI today. So it gets stuck in an infinite loop, and you can totally imagine what happens when this basically goes on infinitely. It's gonna use up all of your resources. You'll be out of tokens, you'll be out of credits, and this is just on your personal demo. But imagine this happening at an enterprise scale. That would be extremely scary. If a user is asking for something and it's stuck on this infinite loop, you not only lose the resources, but you would also lose the trust of the user who's actually using this. Secondly, tool misuse. So this could be something which is so malicious. So there's something called as prompt injection attacks, which is when you hit a specific API and you pass corrupted data to it and it executes, then there could be any sort of malicious leakage of your personal information, or it could also be a loss of your personal data. And this is extremely becoming common, and there's a lot of cybersecurity attacks and courses which also handles and talks about the tool misuse. Finally, the unpredictability. So you're not sure, although you provide the plan to the agent, it's not really predictable, right? Because some of these websites might have a news about AI, sometimes it might not. So this is just a estimate that you can say that you would look at these websites. It's not, like I mentioned, it's not deterministic, it's more probable. So it could take multiple paths to solve the same goal. So that's about the agent. Let's look at the guardrails framework. We talked a lot about how the AI could be misused and how the prompt injection attacks the reputation and also your personal data. So let's look at the framework which helps secure us from all of these fronts. Firstly, we're talking about proactive measures, and these are not reactive fixes, which means you would need to make sure all of these are implemented even before you actually start rolling it out to the users. So this is not an afterthought. This needs to be done first. So let's start here. We started the input layer basically. So this is where the PII masking and the intent filtering happens. When what exactly is PII masking? So PII is personally identifier values such as the MRN, SSN, date of birth, and multiple things like that. So how do we do the masking is using regular expressions, which is the most basic form. An SSN is basically how much is it? I think 10 digits. So you basically see if there's 10 digits of numbers, which is of this format, then make sure that you're masking it. That's the first. Secondly, the intent filtering. You basically look at any sort of injections. So when I say injections, this could basically be the code which is implemented within the prompt. So there were a lot of different cases where the prompt in the earlier days had text such as reveal your system prompt. And that could be a huge lawsuit. And this could be something which is very bad because it's going to reveal all the company's secrets. So the first step should always be PI masking and intent filtering, making sure that you're not allowing any attacks to your LLM system. And secondly, at the output layer, what you would need to check is the facts. Do you remember the grounding, which I just talked about earlier, where you're looking at the system responses and making sure that it's actually quoting where the answer came from? You would need to do the same at the output layer to make sure the responses are not just made up using hallucination. These are actual responses. And finally, the brand voice. You've seen a lot of ChatGPT responses. It has the M dashes. It's so robotic. It's not really aligning with your brand. So you would need to give sufficient context in the prompt to make sure the responses are in alignment with the brand voice. This could be maybe your brand is very Gen Z. So having all of those words which aligns with Gen Z as opposed to a very, I would say, very established enterprise. And finally, the monitoring. So what exactly is drift detection? So basically, you need to make sure that the model performance continues to be along the same scores as opposed to it degrading. This model degradation can happen due to various reasons. This could be due to a changing data set. Maybe sometimes the business logic has changed, the way the business is being done has changed, but the prompts still remain the same. So this causes drift, a lot of drift and also degradation in the model performance. And finally, the cost and latency. I think we definitely spoke a lot about it. If not really monitored properly, the cost and latency could cause significant loss in terms of resources, as well as latency would cause loss of customers. The human in the loop is very necessary in at least within the first initial days when you're still rolling out the product. There should be someone who says, yep, this is looking good, and then you can start flying solo with just the LLM. But human in the loop is probably essential for the places where there's a lot of branding, advertisement, and also for very regulated environments. All right, let's look at a little more technical uh, topic right now, which is evaluations. So evaluations of Gen AI is not the same as what we have in traditional software. In traditional software, we would just have a huge test set of use cases, such as TC1, did the user log in? Did they see the submit button? Did they click here? What did they see? So there's a deterministic path, but in terms of Gen AI, there's no such deterministic path. So we have these different metrics, which is going to help in understanding how we evaluate them. Firstly, we need to have something called as the golden data set, which is a set of, if you're implementing a RAG, you have a set of questions and you have a set of responses. Let's say there's 50 questions and you have 50 responses of what the user should see. If they ask for what is Mary Jane's birthday, they should see this specific response. That's the golden data set. So what is faithfulness in that context? The degree to which the answer is derived strictly from the provided context. So this directly ties to the grounding. Is the data that's coming from the database, is the data coming from the LLM resonating with what's in the database? That's the faithfulness. You basically compare both of that and see what the score is between 0 and 1. Higher the score, higher the faithfulness. Secondly, relevance. How directly and completely the answer addresses the user specific query. If I am asking for user's birthday, it should give me the birthday and not the address of the user. So that's the relevancy. It's pretty easy to understand that. It's intuitive. And latency, how much time does the user have to wait until they start seeing the chat GPT or any sort of LLM responding? If I were to use an LLM and seeing about like 3 or 4 seconds or more, then I would start going impatient. And this is something which is very important, kills a lot of different products. So time to first token needs to be as less as possible. Finally, the override rate. You basically see what the AI generated content is, and also make sure to have a disclaimer whenever you use a Gen AI product that this response is AI generated. It may not be reliable. That's just something which is going to save a lot of compliance risk and also a lot of reputation damage. Finally, we spoke a lot about different things. I would like to leave you all with this very cute acronym. It's called TRUST. So you start off with the specific use cases. Don't start with, I'm going to boil the complete ocean within the company and make it all Gen AI, because that's rarely going to work. You start off with just a small handful curated set of use cases. You focus on one specific problem within those use cases and say, so this takes this much of time. Using Gen AI, I'm going to reduce it by X%. You start small. Secondly, make sure you have the data that's associated with all of these different use cases. You have the metadata and you're following the complete architecture, which I showed you earlier for the data quality, freshness, making sure you have audit controls and all of that. And thirdly, you're using the subject matter's expertise in order to iterate over the prompts. This is going to be the this is going to be the heart of the logic of the LLM. The prompting should really reflect what the subject matter experts expect. And the generic prompts from ChatGPT is never going to work. It's not going to help move the scale. So this is very important, need to spend a lot of time there. Thirdly, scalable evaluation. Like I mentioned, you should have something called as a golden data set, where you have a specific set of questions and responses. What's the expected response? And you need to use that in order to calculate faithfulness, relevance, and all of that. And finally, the audit trails need to be stored, which means you need to have a specific database on the back end, like a telemetry, which is capturing all of the things that's happening with your LLM and the RAG agents. So basically, what did the user ask for the question? When did they ask it? How did the question flow through my complete architecture? Which means, how was the embedding looking like? What are the chunks that's retrieved which matches my question? And what's the faithfulness score? And is the response really correct? What needs to be done? So you would need to store each and every one of those data points, because these are your audit trails. There's a lot of I've seen a lot of AI regulation and governance that's happening in all the different teams and offices. So when they come to you asking, why did your product recommend me this $5 million solution? What's the basis for it? So you would need to have some sort of backing to show why it did what it did. So that's the audit trails. So you would have the privacy controls such as the PII masking, and finally red teaming. This is something which is gaining a lot of popularity now. So red teaming is nothing but you're preparing and setting up your team to be doing the evaluation on a daily basis. You start tricking the LLM, asking all sorts of questions. Go to your when you go to your company today, you can ask a question to the LLM which you use. Hey, can you give me the SSN of this person? Hey, can you show me what's the salary of that executive? So that way you start tricking and seeing if there's any sort of loopholes that you can catch, then that's the best case scenario, because it's better you catch than the customers who catch in the production. So that's red teaming. There's a specific team who's dedicated to just do this on a daily basis. All right, so let's now go to the case study. We talked a lot about different frameworks, architecture, types of AI. Let's apply this to one specific case study. So let's assume this person is working at a company where, let's say it's a customer support company, and they have about 5,000 pages of technical documentation. And this company, it basically sells about 20 plus products. So this customer representative would need to have all of the information on the tips of his fingers when he responds to the users. So the problem is 60% of the time is spent searching for the information as opposed to talking to the customers. So imagine a place like Amazon, if they did not have any of this AI, and you're a customer, you're asking, hey, what went wrong with my headset? Why is it not working? I just brought it 10 days ago. So this customer representative would need to actually find where the information is about this headset, zoom in on that particular catalog, and look for that information on what are the things that could go wrong. So of course it's going to take a lot of time, and which is why 60% is a lot. So this is the point where we could easily use Gen AI and solve this person's misery. So the pain points is basically high resolution time, which is they spend a lot of time putting the customer on hold. You'll be listening to some nice music while they look up the information and provide the response. Secondly, the agent burnout. Imagine if the same person gets about 15, 20 different calls the same day, how much of a burnout that person would need to face. That's a lot. Finally, inconsistent accuracy. So let's face it, we're not really able to consume all of this information in few seconds and able to give the correct, accurate version of the response each time, because the person is already burnt out and we don't really know where have I even looked at all the different pages to give the correct answer. So what is the response for this then? Like, what's the solution for this particular problem? Again, let's go back to the trust framework, but let's look at each of these features that we can use to solve this agent's problem. Firstly, RAG, which is retrieval augmented generation, which means you're feeding a lot of unstructured data to the LLM, the 5,000 pages which I talked about. All of these pages are converted to something called the embedding and stored in the vector database. So that's the RAG. You basically do the targeted troubleshooting just for this use case, and then you add metadata. So when I talked about the 5,000 pages, each of these would have 20 products, which means each of these products would of course have a metadata. One could be about suitcase, one could be about headphones, the other could be about, let's say, face mask. So you would need to add necessary metadata for it to identify and zero in on that. And then prompting. So prompt could be something like, hey, you're a customer support agent who helps identify the responses to the user questions quickly and answer correctly. So that could be the prompt. And finally, the evaluation. This could be making sure you have the golden data set. If the person asks what went wrong with my headset, you would then show what the response should actually look like. Maybe it would be like, have you checked your warranty? That's step one. Second one could be, what is something wrong with your mic? That's the next question. So you have a bunch of answers. That's the gold labels. And finally, making sure that there's no PII masking. sorry, making sure that there's no PII which is being exposed. So applying this, we were able to narrow down to troubleshoot this specific category. This reduced the complexity by 80%. And finally, we have the metadata, which is tagged to each one of these products to prevent any sort of hallucinations. And we have retrieved the scope for the we have the specific prompt using SME's input, making sure that it's reliable and fitting with the brand voice. And we have the golden data set. Finally, we're doing the governance. So that's the case study, and I hope that helped. So finally, to wrap up, I have this 6-step roadmap to production. These are the 6 different things we need to keep in mind while pushing the demo to production. First is you define success. What does it look like? You have the golden data set. You build each of these agents or RAG or any sort of assistance, and you implement all of the guardrails that's necessary, and make sure that you're running the AI in background, not really exposing all of the information in the front, and make sure that there's no sort of hallucination, there's a lot of grounding, and always take the user feedback, start off with that small group of people, and then iterate slowly as opposed to starting off big and failing massively.
Thank you so much
Thank
for
you.
your time today. Really appreciate. Happy Friday. Happy weekend, everyone.